That's good. Okay. And couldn't we multiply? Yeah, okay. All right. Okay. Determine and plot the corresponding current, and we have a capacitor. Okay, so we want to look at our formulas for capacitors. And for capacitors, we see that current is C dV dt, and we have, in our problem, we have voltage. So current is C dV dt. And we know that the derivative is a slope. And so when I look at this graph, I want to find dV dt. I'll find dV dt on the different parts of my graph. So from negative infinity to 4, what is dV dt?
Zero.
It's 0. Okay, and then from negative 4 to negative 2, the slope is the change in y over the change in x. So the change in y is 100 volts over the change in x is 2 seconds, and so our slope is 50. Yes?
You have 4 non-negatives.
Oh, thank you. Up here. Yeah. All right. And then from negative 2 to positive 2, dV dt is 0. And then from 2, this time really to 4, you can just look at it and say, oh, that's the same as the other one, only negative. Or you can say it's the change in y is negative 100, because it's going down over the change in x is 2, and you'll get negative 50. And then from 4 to infinity, we have 0. So that's all you need to be able to plot the current. So your time axis is going to be time in seconds, and your current axis will be current, I think in amps, yes, because it was volts. So like if it was millivolts, then it'd be milliamps. And we have numbers, our numbers are 0 and negative 50 and positive 50. So negative 50 and positive 50, negative 2, negative 4, 2, and 4. And so we can say it's 0 until we get to negative 4, and then it becomes 50 until we get to 2. And in engineering, they draw those vertical lines. Yes?
I was just wondering if that 20 microfarads ever comes in.
It does, yes, thank you. So this is not right, because I always forget to multiply. I always forget that part. I got the dV dt, I didn't get the C. Yep. So the C is the 20 microfarads. So I have to multiply each of these by 20 times 10 to the negative 6. So this would be 1,000 times 10 to the negative 6, which is the same as 1 times 10 to the negative 3, which is 1 milliamp. So, and then I'll get 0 here. And then for negative 50, what's that? Oh. And then, so for negative 50, I get negative 1 milliamp, and then 0. So our graph should have looked like I in milliamps and 1 and negative 1. So then it's 0 until we get to 4. and then 1 till we get to 2, and then 0, and then -1, and then 0. Okay, then the next part of the question says, what is the energy stored in the capacitor at time t equals 1 second? So at time t equals 1 second, we are right here. And so there's a couple ways we can do this. So one way is a straightforward way that the energy is 1/2 CV squared. Well, what is V? It's this graph up here. So we can look at the graph and see what V at 1 second is. What is the voltage when we're at 1 second?
100.
It's 100. And so V at 1 second is 100. So that would be 0.5 times 20 times 10 to the -6 times 100 squared, which is 10 times 10 to the -6 times that, so that looks like that's 0.1. Oh yeah, just 4 zeros. 4 zeros. And so that gets us 0.1 joules. There's another way we could do it. We have now the voltage and we have the current, and so you could do a graph. If you had to graph the power equals I times V. Let's see how we would do that. So we know that I was 1 milliamp. Where was I 1 milliamp? Between -4 and -2, and it was 0 everywhere else. And so we know that I was 0 here, 0.001 here, 0 here, 0 here, 0.001 here, and 0 here. So we could graph our power, and it would look like 0.001 times 100. What is 0.001 times 100? 0.1. And so our power would look like this. It would be very similar looking. It would be here, and then it would go up to 0.1, but then it would go down to 0, and then it would go down to -0.1. And then back up to 0. So that's what our power would look like. And in order to figure out how much energy would be stored in it at time 1, you would take the integral of power. So you would get the area of this triangle. And the area of that triangle is also 0.1 joules. So just another way to do it. Okay, are there any questions on this one?